So welcome to the second lecture of APRG. Let me switch to this thing. So, should we start? There are still not too many students here, but anyway, let's start. So today what we are going to do is to see a bit of Python syntax. So recall last time what we talked about was some generalities about Python and programming, and we said we distinguished the declarative inductive style of programming in Haskell with the procedural programming style of in Python, where you create procedures or functions which will do tasks for you, and you explicitly describe how to perform a particular task rather than give an inductive definition of it. So now let us get down to the basic Python syntax. So at the very at the minutest detail, at the smallest granularity, you have names like we talked about last time and values. Correct? So what are names and what are values? 5 is a value, A is a name. So names are also called variables in other languages, and values are what you want to compute with. Correct? So you want to keep track of the values which you store in your program, and you do this via names. So you have named values and you manipulate them. And the simplest statement in Python is the assignment statement, which is something like name is equal to some expression. So for example, you can write, you can write, this is the symbol for a comment. So you can write something like A is equal to 5. This assigns the value 5 to A. Or you can say B is equal to A plus 6. This puts, so after this, A is equal to 5. Equal to means that it's equality. It's not assignment, but equality. And here you would get B equal to 11. Correct? So assignment we should distinguish from, this is assignment. These are assignments. And after this, if you check, if you say if B equal to 11, then print something. Suppose you execute this piece of code, what would happen is that it would print something, and otherwise you print something else. And in this case, when you execute this piece of code, you would get the statement something, correct? So these are assignment statements. In other languages or in pseudocode, you often write something like B is equal to A plus 6, or B is assigned to A plus 6. All of them are basically done via this equal to mark, correct? This is assignment. Remember that, correct? Now, we have talked about names and values, correct? So, values all have types. Correct? For example, 5 is a value with type int, correct? Similarly, if you say b equal to 5, c equal to this thing, then c will get either true or false. So, or rather simply, let's just say, no, let's not confuse. So let's say true or false are values with type Boolean, correct? So correct. And variables, on the other hand, do not have types. So names do not have explicit types. So you can say A is equal to 5, A is equal to true. And if you execute them, then first A will take the value 5, and thereafter it will take the value true. Correct? So names do not have explicit types, values have types. And the value stored in a name can take different types depending on what you assign to it. Correct? So this is in contrast with languages like C or C++, where you declare in C, C++, Java, you declare that a variable has a particular type. Correct? In Python, names do not have types associated with them. Is this clear?
Yes, sir.
Okay. So, so one thing, types in, so in some sense, Python types are dynamic. As opposed to static. So what does this mean? This means that the type of the value that is stored in a variable is determined at runtime. You cannot determine it by looking at the program only. The type might depend on, only when the program is executed would you know what the type of an object is, in many cases, correct? So types are dynamic, but at the same time, this is as opposed to C++ or C, wherever, where variables are types. So you know beforehand that all the values that any value stored in this variable must have this type. Correct? You get my point?
Yes, sir.
On the other hand, the types are also, Python types are strong as opposed to weak ones. To weak. And this is again in C++ and so on. What does this statement mean? This means that there is no implicit conversion of types between objects. If you have something of a one type, it will remain that type for good. Of course, there are some exceptions to this. So in a strong typing system, the type is determined. So the type of a value is unique and fixed, correct? And there are some caveats. So this is in Python again, correct? So for example, correct? So I will not, so without introducing too much about types, I will not say too much about this, but there are some exceptions. For example, you can add a float to an integer, and the resulting thing will be a float. So the types are not strict, but they are strong, correct? So in Haskell, objects are divided on the basis of types. They are partitioned according to types. So
objects as in like any values that
any values. I should not say objects. I should say values are partitioned on the basis of types, correct? But here you can do operations on floats and ints together, or there are some standard values which you convert. For example, if you say x is equal to false, and then you do y is equal to x plus 1, this should give an error because this false is of type Boolean, and x plus 1 is integer, this thing, but this works. It will interpret false as 0 and add 1 to it. Okay.
So it would return an integer.
So you would get an integer. Yes. So
sir, you said like a second ago, you said types are strict but not something. Could you repeat that?
So the types of Python types are strong but not strict.
Okay.
Correct. Strong but not strict. Tell me.
So in C, C++, Java, the type of the value is not unique and fixed?
No, it depends. You can implicitly cast values into something else and things like that, especially in pointers. So there is a whole spectrum of types, but it's in general, it's weak. It's not strongly typed.
Okay, thank you, sir.
Okay. So now let me talk.
And like,
okay. Sir, I didn't understand what you read. X equals false. After that, y equals x plus 1. Can you please explain that part again?
So false. So you would think that this leads to an error, correct? Because you are adding false 1 to false, correct? False is of type Boolean and 1 is of type integer. But then we will interpret false as 0.
Okay, sir. Okay, sir.
Python will interpret it as 0 and return 0 plus 1 is 1.
Okay, sir. Get it. Okay, sir. Thank you.
Okay.
yeah,
Okay.
sir, is there any precedence order about the implicit conversion taking place right here?
So there is no implicit conversion. It is
Here,
some sort of
here between bool and integer, it's getting implicitly converted to int, and then between int and float, you said 1 plus 2.1 will get converted to float. So there's implicit conversion, right?
So it's in some sense, I think I'm out of my depth here, but I think you can think of every integer being a float also. The types are, yeah, so let me not belabor the point about the subtlety here, because I do not know very well. But the thing to remember is that the types in general are strong, and especially so one thing is that you can overload your plus operator to take things of different types. Correct? So later we will see that there are objects, there are classes, and there are objects, and you can define a add operation in objects which can add. So you can add two different objects of two different types to give something else. But let's not go there. Correct? Let's not jump this thing. Correct?
Sir, sir, what exactly do you mean by strong and weak? I'm a bit confused here.
Strong and weak basically mean, strong means that there is a unique type for a value. Think of it as that way. And weak means that the value, the value has a type, but you can change it to another type implicitly.
Also, like 2 can be interpreted as a float and an integer.
As an integer, yes.
Okay.
Float as well as an integer. Correct?
But in Python, it is just an integer.
Just an integer. And it's a property of plus somehow that when you add a float and integer, you get a float.
Okay, yeah. Yeah.
Correct?
Thank you. Yeah.
So what are the basic types? So you have integers, ints, floats, and you don't have chars. Instead, you have, we will see in a minute, you have the type string. So even a single character string is a string. So this is a string. They have done away with single characters as a different type.
But sir, these are just names, right? Like you were saying it's a string, and some in some other language it will be called a character. That doesn't make a difference, right?
It does not make a difference in the sense that we are talking about Python right now. So Python basic types, and in Python, a string is any sequence of characters. Any sequence of characters, correct? And that is a basic type. It's not, it's to be distinguished from, I mean, there is no character type. In C, C++, for example, you will distinguish between things like a single character C and a string of characters. Here, that distinction is not there. Okay? So let's reserve this for a second, and we'll talk about ints and floats first. So what are the operations on these? The usual arithmetic operations, plus, minus, product, and division. Correct? And this is always a real division. So if you do 2.0 divided by whatever 4.0, this is equal to 0.5. Correct? And even if you do 2.0 divided by 1.0, you will get equal to 2.0. Correct? So this is always a real division. On the other hand, there is, for integers, there is this percentage, which is essentially the mod operation, which we saw the last time, and there is also the div operation. Correct? So for example, if you say percentage 2, that is equal to what? It will be 1, because 5 mod 2 is 5 is congruent to 1 modulo 2. Correct? And similarly, 5 div 2 is equal to 2, because basically floor of 5 by 2 is equal to 2. Correct? Do you agree?
Yes.
Okay. Moreover, so you'll have to
Oh.
figure out
We don't have any explicit type conversion, some sort of like if we divide 5 by 2 and it would give 2.5 and then explicitly convert to int. We don't have that.
You can say int of something.
Okay, so that will make 2.5 to 2.
Huh.
Okay.
So there is an int operation which converts a float to an int, but it's an explicit operation. Correct? You have to do it explicitly. And then there are, of course, there is equal to, less than, greater than, less than equal to, greater than equal to, and not equal to. All these are comparison operators, and they return a value which are Boolean. Return values which are Boolean. Correct? So the values are true or false. So for example, if you say, so you take this, you say this x is equal to this operation, and you say print x, then it would print x. So it would print, what would it print? True. Correct? So this has returned the value true. This this operation 5% 2 equal to 1 has returned the value true. Correct? And for Boolean operation, Boolean types, you have operations like or, and, not, and possibly more, probably more, which you should you can find out yourself. Correct? So XOR and such things would be there. NAND, I don't know, something like that. Correct? So is this clear?
Yes.
Correct? So you can write if x percentage y equal to z and something else, x is greater than 1. I'm just writing some sample this thing, then you do something, and this would take the Boolean value here and the Boolean value here and AND them together, and then do an if on that. So it would use this Boolean value. Correct? Okay. So having said that, let's get back to strings. So we have what is a string? A string is a sequence of characters. Characters are not fundamental types, but there's no char type, so to say. Correct? So for example, you have things within single quotes. You can have things within double quotes and within single quotes, and you even have triple quotes. Something a long line spanning several new lines. Correct? So This is useful when you want to quote long texts and you even want to include single quotes and double quotes inside this triple quote. Then you use this triple quote, correct? You can even write a triple quote like this. This is an example. Do you see my point?
Sir,
Tell me.
I don't understand the difference between single and double quotes. I mean, when do you use it?
There is no difference actually.
So you can use either. Like when
You can use either, yes. You can use either. And triple quotes are somewhat different. You don't have to escape new line. You don't have to. So new line character can be embedded inside a triple quote. Moreover, you can embed single quotes and double quotes inside a triple quote without escaping them by backslash and so on. Correct?
Okay.
Okay. So a string is a sequence of location of characters. Correct? Now, just like string, you also have something called a list, is a sequence of values. These values could be anything, correct? So for example, you can have a list. That a list is usually shown by the square brackets, between square brackets. You can say L is equal to 1, 2, 3, something. So, and you can even put a list inside that 1, 2. Correct? So these are the values which belong to a list. They don't have to have the same type. They can have different types. For example, this, and this are ints. This has type string. And this has type list again. Correct? Am I clear?
Yes, sir.
So what I'm saying is that the values in a list do not have to have the same type. Correct? They can be of different types.
So, sir, since there is no character type in Python, so the functions that we can use in suppose C++ on characters like to upper or is upper, like, so those can be done on in Python on string values.
Yes, I presume. So yeah, so depends on the library functions that you're using, and I think to upper and to lower would be like that.
Okay.
Correct? You'll have to check the exact definition of the corresponding functions, but yeah, correct. So lists and arrays are different. And in Python, in base Python, there is no array. There are packages where arrays are there, the array package, I think, or some such, which we might go into at some point. But for most of the course, we will deal with lists as the basic. I mean, lists and other data structures, but lists are, we will not deal with arrays so often, correct? Now, so if you have a list, L is equal to A, B, C, and something, correct? So D. So how do you access the elements of a list? So they are accessible via indices. So 0, 1, 2, and 3 in this case. And basically L0, if you write L0, that evaluates to A. correct? So it is the 0th element of L. L0 is, correct? And so on. There is also a way to access things from the end. So you can say -1, -2, -3, and -4. So you can just say L of -1, and that will be equal to D. Am I making sense?
Yes.
L of -4 is equal to A, equal to L of 0, correct?
Sir, what happens if we say L of -5, like it's
If you
negative?
say L of -5, that's an error.
Oh.
So anything outside the range, this defines positive things from 0 to, or non-negative things from 0 to the length, length -1, correct? So anything outside any index access outside minus len of L dot to len of L -1 causes an error. Correct? Index error. Correct? Am I making sense? Yeah.
Yes.
Okay. So yeah, and so this is a generalization of the rule which I should have mentioned earlier, that all names must be initialized before being used, before their value is used. So if you just say your only statement is print A, that will raise an error because A would be uninitialized. You would not assume that A is 0 because we don't know the type of A, we don't know anything about A, correct? A could be anything. So unless you initialize A, I mean, this is not true in C, C++, so on many a times, because you have a type of the object and you can give it some default value of that type. So, but here you have no information whatsoever about a name until you initialize it. So you cannot use that value at all. Correct? Similarly, because these lists, you don't have any information to the value of an element of a list before it's initialized, you cannot use that value at all, correct? So it will raise an error. Am I making sense?
Sir, could you repeat that? I didn't understand why it gives an error.
It gives an error because it's not defined and you have no way to second guess what that value could be. There is no default value, so to say.
So when we initialize it, what's happening? Like, how does it?
So if you say A is equal to 1, print A, then there is no error. I should not have done it this way. I should say, on the other hand, if you say A is equal to 1 and print A, then of course you know the value of A and it will print appropriately, correct? So this is correct, this is wrong, correct?
Yes.
Okay. So if in a list, if we initialize some values, then can we use those values?
Yes, yes.
Oh.
So if you say, for example, L is equal to 1, 2, 3, then you can use L0 is equal to, then you can say L0 and L1 and L2, and you can say similarly L -3, L -2, No, yeah, and L minus 1. These are all defined. Everything else is not defined. Correct?
Okay.
Correct?
So, sir, will it even show an error if we write a equal to 1 after printing?
If you write a, no, so tell me again. You say L is equal to 1, 2, 3.
No, I'm saying we use it somewhere and after that we declare it. So, I mean, is the program, will it, I mean, anticipate that or?
No. You are saying
like first we write print A and then after that somewhere we write A equal to 1, like that.
Then of course it will be an error, because later on so Python code is interpreted, it is not compiled. There's no compiler per se for, correct? So you run through the code, you just as if you would mentally execute the code, whatever is written, you would do it in that order. And when you reach a line, then the things on the left hand, on the right hand side must be defined.
Okay.
Correct?
Yes.
Is this clear?
Okay, yes, sir.
Okay. Now, so there are some functions on length, some functions on lists and strings which are common, which are similar. So for example, len is one such function. Len of L returns the length of the list, or the list L. Correct? Similarly, len of S would return the length of the string S. Correct? Assuming that L is a list and S is a string. Correct? Similarly, you can do L1 plus L2. This plus operation is concatenation. Concatenate L1 comma L2. Correct? So for example, if you say 1, 2, 3 plus 4, 5, 6, this would return 1, 2, 3, 4, 5, 6. Correct? Similarly, if you say something plus else, this would evaluate to the string something else. Correct? And you have, you can do L1 times an integer like 2, and that would give, that is equivalent to L1 plus L1. So it would concatenate L1 with itself. Correct? Are you with me?
Yes.
Just like Haskell, here the string is also considered as a list.
No. So now I'm coming to the point where what is the difference between strings and lists? A list is not a list of characters. A string is not a list of characters. There is a difference. Okay. So the difference is that, so I'll come to it slowly, but if I don't tell you explicitly, then remind me in 5 minutes. Correct? So you have names and you have values. Correct? So if you say, so here I draw the name and here I draw the values. Correct? So if you say x is equal to 1, then you have this name x, and that points to the value 1. Now you say x equal to 2, or even you say x is equal to x plus 1, then x starts pointing to the value 2. Correct? So this is when the values are integers. Correct? Similarly, if you say y is equal to true, it will point to the value true. So in some sense, the values, and if you say y is equal to negation of y, not of y, so you say y is equal to not of y. I think that's how not is. Can somebody confirm that it is this or this?
Sir, I don't. I think Python uses not the word, like literally the not keyword.
Oh, not. Sorry. I got confused. You are correct. So y is equal to, yeah, that's what we saw earlier. So not a y. Then this y would start pointing to another constant, false. Correct? So these values, ints, floats, and Boolean values are immutable. You cannot change the value. Whatever this thing is points to, if you change, if you do an assignment on the name, the value to which it points is it's a new value. Correct? You cannot change an integer, you cannot change a float, you cannot change a bool. On the other hand, if you take a list, you can change a list. So let me make that clear. So suppose you have a list L, correct? So this is the name, and this is the value. So suppose you say L is equal to 1, 2, 3, correct? So what this does is that it points to a value which consists of 3 things, and further each one of these points to something 1, 2, and 3, which are integers, correct, in this case? Do you agree?
Yes.
Now you say something like L0 is equal to 100. Then what is going to happen?
Sir, the value in the list will change to that point will change. The place it's pointing to will change.
Correct. So you would remove this pointer, so to say, and point it at 100. Correct. But so this has side effects. So if you have say L1, so after that you say L1 is equal to L. So what is going to happen? L1 points to this. Correct. Now, will the value of L1 0 also change?
No, sir. No, sir.
It
Yes, it will change.
It will change.
Oh, yes, it will change.
Because these values are mutable values. Lists, so I'm talking about lists now. Lists are mutable. You can change the value of a list. Okay. The value was this object, which had 3 elements in it, and they were pointing to some things. Now you have done L0, you change the value of L by changing the value of one of its elements. Correct? So let me take an example. Suppose this is one piece of code, and now another piece of code is L is equal to 1, 2, 3, and L1 is equal to 1, 2, 3. No, sorry, L1 is equal to L still. And now you say L is equal to 100, 2, 3. Correct? Now
is it like every basic types are always mutable and any derived types are always mutable?
So basic types
because
are
basic
immutable.
types are
Basic types
yes.
are immutable.
Yes, because they are apparently getting stored. Like number 1
Yes.
can't be referenced.
Yes, are immutable.
So A equal to 1, B equal to A, then A equal to A plus 1 doesn't change, just B.
Yeah, it does not change B. Yes. So if you say A is equal to 1, B is
So
equal
B
to
basically
A plus
creates
1.
another. Yes,
B, A is equal to A plus B is equal to 1 second. Let me write your example. It's a very good example. A is equal to A plus 1. Then B is still equal to 1 at this point.
So basically, while B equal to A statements create B, which is like points to different one than A did.
Yes. Yes. So you can think of this as A being pointing to 1, B being pointing to 1. And when you change A, then you change the pointer of A to 2. You do this operation, A is equal to A plus 1, that gives 2. And now A points to the new constant 2. B, on the other hand, does not change. Correct? So this is very important in this thing. In lists are mutable. Lists are mutable. They can be changed. Correct? Now, what about strings?
Sir, you were writing something on L is equal to 100, 2, 3. Could you finish that?
Let me finish that. That's a good point. So now tell me what is L1 equal to, L10 is equal to. Here we saw that L10 is equal to 100. Correct? Now what is L10 equal to?
It's still 1.
Still 1. Yes. Because you have, in this, if you see the execution, what will happen? L points to 1, 2, 3. L1 points to what L is pointing to. Then you change L is equal to 100 to 3, which is a new list. You created a new list and change this pointer to point to this. So the pointer of L1 does not change. L1 still points to 1, 2, 3. Correct? Are you with me?
Yes, sir.
Correct? So L10 remains this thing. Correct? Give me 1 second. Hello? 1 second, 1 second. Yeah, tell me. Yeah, so strings, are they mutable or immutable? Anyone? So strings are a basic type and are immutable, are not mutable. Correct? So which means that if you say X is equal to something and you'd say X0 is equal to question mark, something like this, then this will raise an error. You cannot change a string. Correct? Are you with me?
Yes.
You cannot change the value of a string. They are immutable. Correct? That is a basic difference between strings and lists. But there are many things in common between strings and lists, and like len and addition and so on. And something which are also common is what are called slices. Okay, so what is a slice? If you have a string, let's do it for lists first. So if L0, L0 is the first element of L, correct? Now you can also slice it using the colon notation, correct? Or let us do it next time. Let us do it next time. Correct. So.
Sir, could we access like can we say print x0 and will it give us s?
Yes, yes, you can access it, of course. So here, if you say this is not there, you say print of x0. This will give you s. That's correct. Correct. More questions? Tell me. Do you have any questions?
But sir, if it does not give a, if it gives s when we write print x0, then why does it not happen when we just write x of 0 in that list form?
So we are changing it now on the left hand side and versus the right hand side. You can use, you cannot change. So if you say x0 is equal to something, that means you're changing the value of the 0th element of x, correct? Meaning you're changing x. You cannot change x. I mean, you can change the value of x. You can change what x points to, but the constant that is contained in x, you cannot change that. Do you see my point? If you don't see it, tell me.
Okay, so that means that it, when I write it inside a bracket like 0, so that only takes values when it's a list, but because it is not.
This x0, x1, these are all defined, even when x is a string. Correct? But this a string, if you want to change the value of x0, so think of it this way: you have this x, and this points to something which is a string. Correct? So this is something that resides in memory. Correct? And you want to change this a string. Of course, you can say x is another string. You can do this. So then x would point to another string, and this is valid. But if you want to alter the thing that is contained in x, the value that is contained in x, you cannot do that. This value is immutable. This value is immutable. You cannot change it. You can change the value to which x points, but you cannot change the value, the value itself. Do you see my point? If it's not clear, ask me.
Yes, sir.
It's clear, na? I mean,
yes.
You cannot tamper with the value that is contained in here. The name might contain a new value altogether, like another string. But if you want to change the this a string, you cannot do that. This value is immutable. Correct?
Yeah.
So what you can do if you want to, you can do. So I've not taught you about slices, and we'll see next time how to extract some substring of a string and so on. We will see that next time.
So one question: is the increment of operator there in Python? Like
the increment operator is not there in Python.
Okay.
So you can say x is equal to x plus 1, but this is valid, of course. But x plus plus is not there. Is not there. Correct? or plus plus x. This is not there. Yeah, more questions?
So x equal to x plus 1 just changes the pointer. It doesn't change the value of x.
Yes. So in this case, it changes the what x is pointing to.
Okay.
X plus 1 will be executed, which would create a new integer.
Okay.
Correct. Now, of course, this also depends on what x contains. Correct. What is the type contained in x? If here I'm assuming that it's an integer, so it will point to a new this thing. Yeah. So in some sense, what you're saying is the value that is contained in x does not change, which is correct. Yeah. More questions, clarifications? Nothing? Okay, so I have picked a set of 3 TAs, and I wanted some input from you people. I don't want it just now, but the earlier the better. Would you like some help on the practical aspects of Python and programming and systems and so on? I have heard that not everything is clear to you on how to use Linux and things like that, especially with this batch, because you've not come to the campus and things like that. So can you decide among yourself whether you need some practical help getting started in Python? Correct. And I will instruct or I would request the TAs to help you with that, to keep a tutorial session, if that is the thing. So can you tell me? Tell me.
Sir, I just wanted to ask, do you prefer us using Linux for the course, or is Windows okay?
I mean, I would prefer if you use Linux. I mean, why would you use Windows?
Okay, sir.
I mean, I can't prevent you from using Windows, but of course, I mean, you should use Linux. So, I mean, would you, so some class representative or somebody from the class, can you inform me whether people want a tutorial session? And it better be early. Tell me.
Yes, so I'll ask everyone today and I'll get back to you by today evening itself.
Okay,
yes, so we can set up a poll for that.
Yeah, so I'll leave it to you people to do that, correct?
Yes.
And tell me, give me some details on what you want there and things like that. And I'll communicate your request to the TAs, correct?
Yes, sir, we'll do that.
Okay, great. Okay. Is there any other question about the course that you would like to have answered?
Sir, will you also teach shell scripting?
No.
Okay.
I will not teach any shell scripting in this course. So, I mean, shell scripts and so on, I will certainly not teach. If you want some help for basic this thing, then the TAs might help, but it's not very relevant to the course. So the course is basically about algorithms done in Python, and shell scripts doesn't enter the picture. You might need some, yeah. So more questions?
Sir, I have a question about what you've written on the screen about x++ not defined. Could you repeat what you said?
So x++ and ++x are defined in C, C++, languages like that. They are not defined in Python.
No, what do they like generally represent?
x plus plus is, you know what x plus plus is, you know, it increments x, either post increments or pre increments. Such things are not there in Python. So you don't have to worry about them if you don't know them, and if you know them, you can just forget about them in Python.
Yes, sir.
Okay.
So can you repeat the evaluation part of the course? Actually, I missed the first class.
Okay. So one thing is, I will keep the lectures hopefully by today so I will keep both the transcript that whatever I have written in the on the screen, as well as the lectures themselves in a YouTube group. And somebody had requested playlists. I still have to figure out how to do that. Now the evaluation part is that there are 50% assignments, programming assignments. There'll be 5 or some such programming assignment, 4 or 5, 6, something, correct? We'll decide. And then 20% on quizzes.
Okay.
And 30% on NSEM.
So NSEM will be theoretical, or will we have like questions to code in some particular amount of time?
It will all be paper and pencil.
Okay, and these assignments, will you have it on some portal, or will you send a text file and we'll have to send the code back?
You will have to send the code. You'll have to submit the code on Moodle. At least that's the plan right now. I will decide with the TAs. In the past, we have had it on some portal, but I did not particularly. Yeah, so we'll see. Correct?
Okay.
Yeah.
So one more question. So since literally everything is, I think, is in pointer based, so I don't think there is a separate concept in Python called pointers.
There's no pointer per
like
se.
we have in C++. Okay.
Yes, there is nothing like pointers.
So everything basically works like a pointer.
Huh?
So everything is working like a pointer.
Meaning X, when I say X stores a value, that you can think of it as it pointing to that value.
Yes. Okay. Okay. So X is not itself a memory block, or.
So you can, in this one, you can think of these are the names and these are the values.
Okay.
And similarly, even here you have names and values, and these are unnamed, or they are named derived from this, correct?
Okay.
And they are pointing to things. So these are the values themselves are composite. They can be made up of other values and so on, correct?
Yes, sir.
Yeah. So more questions? Okay, so then we meet on next Tuesday, correct? And I will expect some response from your class representative or representatives by tonight, preferably before 8 o'clock, because I meet the TAs at 8. So if you want something soon, then it would be best if you do it early, correct? Okay, thanks. Sir. Okay, thanks.
Thank you, sir.
Thank you.
Thank you, sir.
Thanks. Bye. Bye.
Thank you, sir.
Thanks.
Thank you, sir.
Thanks.
Thank you, sir.
Thank you, sir.
Thanks.
Thank you, sir.